Welcome to Engenius Films, sharing the genius of engineering. If you were an engineer, what would you invent?
A racing car. A racing car with loads of cool gadgets. I just look at the cars through my car window and just look how I could improve them, thinking how it could be better made so it doesn't take that much petrol. And I would invent a car using boat motors to control the wheels.
Cars are exciting. They can, not only are they a brilliant way of getting from A to B, but they can also be a really fun way of getting where you need to go.
Now, engineering is not just all about cars, but for engineering students across the country who are working on the Formula Student project to design and build their own racing car, it is all about the cars.
I went to hear all about it from engineering students at the University of Sheffield and the University of Birmingham.
Formula Student is a team of students from first year to fourth year who design and make a car to race at Silverstone at the end of the year.
When designing a Formula Student car, you sit down and figure out your core aims. If you want to achieve a really light car, or a really reliable car, or both. When designing, you need to find a balance in between weight, reliability and core performance. And at the end of the day, all of these things come down to money. The more money you have, the better car, but it's a lot of engineering experience and knowledge. The better the engineer, the better the design and the better the car.
We first start with getting the chassis sorted because that gives the entire car its shape and its structure. And then we can think about how to attach different components to the chassis.
The best way to think of a chassis is it's like a skeleton, so it holds all of the external components of the car together.
This year I'm working on the chassis and vehicle dynamics team.
Chassis and vehicle dynamics is a combination of two aspects of the car. So we have the chassis, which is the skeleton of the car, it gives it its shape. And the vehicle dynamics, which control everything about the handling or the steering. We also have shock absorbers across the car, and we also include now anti-roll bars, which stop the car basically falling over when it goes into corners at high speed.
In order to take some weight off the car, we'd look at redesigning components and thinking of cleverer ways of doing that design work so that there's less material on the car.
To make the car light, it depends on the material choice and the design of the parts. For example, on our car we use quite a lot of carbon fibre. Carbon fibre is a non-metallic material. It's a matrix of fibres and resin which makes a really strong, stiff structure without using lots of weight.
This year we're moving from steel drive shafts to aluminium titanium alloy drive shafts. A drive shaft is really simple. It's just a tube. It takes the power from the engine or the differential and it takes it to the wheel. So all cars have a drive shaft. You can't get away with that one.
It's absolutely vital that all of those teams work together because otherwise components won't fit together and you won't have a working race car at the end of it.
There's a lot of computer-aided design in the project, CAD, to actually design the car and take an idea to reality.
We model nearly everything on the car, everything from engine outputs to tuning the engine to aerodynamics, forces on joints. Nearly everything is computer modelled on the car, so computers is a massive part of everything we do. Aerodynamics is about air movement over the surface of the car, so the less you have to resist against the air, the faster the car will go, so that's gone into the chassis design.
The static events involve cost, design and business, and then the dynamic events are the slightly more fun ones which involve actually driving the car.
I don't get to drive the car, but other people on the team do.
The car is amazing to drive. It's built for speed and agility. It's really quite something. The acceleration time 0 to 60 is comparable to a Ferrari 458.
The Formula Student is a fantastic way of applying what you learn in the theoretical side of lectures to a real life scenario.
We study properties and applications of materials so that everything that the car is made out of, you have to make sure that it will be strong enough to race with, it's not going to crumple, it's not going to wear, there's no rust, things like that. It'll be able to withstand the weight of somebody sitting in the car.
The really good thing about making a Formula Student car is that it's an opportunity to see everything you've worked towards go into a final car, and then it's magical when you see that car drive for the first time.
The most rewarding part of engineering is seeing the finished product. Seeing it compete on track is just something out of this world.
Everything that you do has such a practical side to it. You can use it in so many different ways.
Engineering is related to real life.
It's a really good way to help improve people's lives, but not only that, it gives you a new challenge every week.